their fate is in everyone else's hands as well as the tiebreakers or however that.
Good morning. Let's lower the volume here. There we go. All right. Good morning, everyone. Thought we would do something different today. We're going to be working on the Pangram exercise on exorcism.io. I'm currently doing the TypeScript track. And for those of you who aren't familiar with exorcism.io, it's a pretty cool website where you get to work on some exercises, and the idea is that you usually get mentor feedback for each of these exercises. So if I show you, the usual way of doing it would be to do it in mentored mode, where you would go through an exercise, then you would wait for feedback, probably refactor a little bit according to that feedback, and then eventually the mentor would approve the solution, and you move on to the next one and to the next one, and so on and so forth. But on the TypeScript track, there just aren't enough mentors for the amount of people submitting solutions. So it's been, my last one I submitted has been, I think, close to a month, and I didn't get any mentor feedback yet. So what I'm going to do, because I'm sick of waiting and I don't know how long it's going to take, I'm going to switch to independent mode, which allows you to basically do whatever you want in whatever order you want. But I'm going to try to follow the order in the mentored track. So anyways, but they're fun exercises, so it should be fun nonetheless. All right, so Pangram, introduction. Determine if a sentence is a pangram. A pangram, Greek pangramma, every letter, is a sentence using every letter of the alphabet at least once. The best known English pangram is the quick brown fox jumps over the lazy dog. The alphabet used consists of I really need to find out how to pronounce this. ASCII letters, A to Z, inclusive, in his case insensitive. Input will not contain non-ASCII symbols. Okay, I know how to do the setup. So determine if a sentence, okay, that shouldn't be too hard. I did the setup. I already downloaded the exercise and the test suite and all that. So we should be good to go. All right, so let's take a look at our first test case here. Empty sentence. Okay, so we're expected to do this with a class, right? That's going to be instantiated with a creator, a constructor function, I mean. And it has a isPangram function. Okay? And we expect that to be false if it's empty. Easy stuff to get going anyways. So export class pangram. Constructor takes in a, let's just call it input or sentence. Yep, let's call it a sentence. Sentence, type string. And no, we don't need to do anything in here really, except that I'm going to make this private. We don't need anyone to have access to that once we've got it in our, what are you saying here? But its value is not used. Cool. We're about to do that. Take it easy. Is pangram, I think, was the name of the is pangram. That's right. Is pangram. Return false. No, it's not going to compile if I don't use the sentence, so this dot sentence didn't do nothing with it. How's that? All right, let's try our test. Import pangram. Did I not pangram? And oh, it's looking for a default Yeah, it's looking for default. Export default class. Okay. Freeze theme. I will at least suck up some frog legs. Nice. All right. I'll keep in mind that you're not necessarily watching the entire time. Property sentence cannot be declared in the constructor. No parameter properties. What is that? Oh, no, hells no. You're not gonna take away this cool feature from me. What's it called? What's it called? No parameter properties. That is one of the things I really like about TypeScript. No parameter properties. Boom. It's going to be false. Probably not going to get any mentor feedback anyways, so I'm going to do my thing. All right. Structure, good. Now I just need to remember how to run tests on this thing. It should be, let's take a look at our package.json. Do we have a script test? As simple as that. Let's do it. npm t, I think, is the shortcut. Yep. And it passes. Lo and behold. Okay. So now let's work on this one. Pengram will with only lowercase. Yeah, well, we don't care, right? Because it's supposed to be case insensitive. And is case insensitive. Okay, so why are we... Oh, because at some point it's going to pass in some... Yeah, okay. Gotcha. So Pangram with only lowercase returns true. All right, so let's do this. If the sentence actually just doing that, I think an empty string is falsy, so this should work. Return false, otherwise let's just return true. Oh, yes. Let's run the test. npm t. Yay! Next test. Missing character X. So we're basically getting a sentence that's missing one character. Okay, so now we actually need to... No, we don't. Watch this. If this dot sentence what do we have here? What do we have? Substring returns a substring as specified within the string object. Just turn that off here. Don't get alerts. I want to try to do something clever just to avoid implementing the whole algorithm for one more test case. Matches a string with a regular expression, returns an array containing the results of that search, and if it doesn't match, probably that's even better. Look at that. Includes. Yes. Includes. Determines whether two strings are equivalent in the current locale. Well, that's not exactly... Oh, I'm not looking at the right thing. Damn, I wanted the description. Includes. There. Okay. Returns true if search string appears as a substring. That's exactly what we want. So if includes X. If it doesn't, then return, well, actually, we don't even need to do that. So yeah, we'll do it that way. Return false. And otherwise return true. Let's see if that will work. Yep. Okay, another missing character. X. What? So it's the same thing? Should just work then. Oh, look at that. I'm like breezing through those tests. Okay. Pangram with underscores. What are we supposed to think about that? Do we care about the fact that we have underscores? It's expecting to be true, so we treat underscores just like anything else, or spaces or whatever. Okay. They shouldn't affect. They shouldn't affect. And my test should still return the correct output. Yes. So we keep going. Pangram with numbers. We shouldn't care about numbers in my current implementation. Shouldn't care about them either. Look at that. Oh, boom. Okay. Missing letters replaced by numbers. Ha. Now that should trip me up because now we're missing more than the X. We're missing a bunch of them. And this is where I'm going to have to actually implement some sort of sensible solution. Yep, okay. So get rid of this. This was just silly. This though is, actually this will also not be necessary once I've implemented what I'm thinking of implementing. What am I thinking of implementing? Actually, let's just do this. Just for kicks, we'll commit that we're passing up to missing letters replaced by numbers. No, we're not passing this one. Pangram with numbers. Passing tests up to, what did I say? Pangram with numbers. To pangram with numbers in pangram exercise. That's pretty obvious, but whatever. All right. Push that up. If anybody's following along, you get the code. Okay. Now I'm just going to delete all of that. So we basically just need to check that our sentence has every letter in the alphabet. Now, first thought was, okay, I can make some sort of table, dictionary, map, whatever you want to call it. And every time you encounter a letter, you just, add a +1 as a value. So the key would be the letter. And then you just do +1. And then once you're done going through the entire sentence, you just look at all the letters in that map and make sure that they all have at least 1 in there. They don't have 0, basically. And if it's true, then you've got each letter. If it's not, then you got false. So that would be one way to do it, but I'm also wondering if would there be a way to do this that would be simpler using character codes instead of actually having to type in like an entire yeah, I think maybe. Because the ASCII character codes are, for the letters anyways, are contiguous, right? The codes, the number, let's see. Just do this. Okay, let's look at the table. It's pretty much what we want, right? That's the whole table? What? It's got to be more than that. Oh, okay, it's okay, got it. Got it. So the letters are starting here. Oh, but then I have to deal with the fact that some are... Oh, that can be easily fixed by putting everything to lowercase. So 97 to 122. So instead of having a map of A, B, and having the keys be A, B, C, D, blah, 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 I can have the keys be 97 to 122. It'll be, I won't have to type it that way. Let's see. Let's see if I can do that. I'll probably initialize that in the constructor. So we're going to make this that, what are we going to call this? ASCII table, ASCII map, ASCII count, letter count. Yeah, let's make it letter count. Like we don't need to know that we're not using the actual letters. Letter counts. Yeah, letter counts. I actually don't need to keep a count. I just need to make sure that there is one in there. So letter. How about letters? How's that? Is that letters? Okay, just need to private letters type. Do I know what am I doing here? Is it going to be a map? Yeah, let's make that a map. Makes sense to have it being a map, I think. It could be just a plain object. Then it might be easier to, well, let's do it with a map for now. We'll see how that works out. And let's see, so our key is going to be a number. That's going to be the ASCII code. And our yeah, our value is simply going to be a Boolean, I guess. I was just thinking for a second, hey, maybe I can do some binary stuff here, but who cares about performance? Yeah. Okay, so that's, I don't need this. I just need that. And then, oh, actually, let's just initialize it right in there, so I won't need to type it like that. So it'll be inferred. So we're making a new map, and it's, what did I say? Number, yeah, number and Boolean. That's all we need. And I could just, could I, is there a, I don't think there is. I know in some languages there is a possibility to basically say, you know, instantiate this kind of data structure with the keys being numbers from 0 to 100, let's say, or something like that. But I don't think that you can do that in JavaScript with any of the data structures, whether it's array or map or whatever. Oh, I just thought there might be another way to do this. There might be another way to do this using a set. See, set in JavaScript, it's a data structure that only stores a value and only one instance of a value. Right? So it doesn't, like if I were to add to a set the letter A and then you know, further down the line add the letter A again, there would still just be a letter A in the set. And it kind of goes with what we're trying to do. We only care to know that we have an A. We don't care that we have 2 A's or 3 A's or whatever. So if we store that, yeah, no, this is still okay. I think that's good. I think that is very good. So let's do this. Set. And now we could even, if we want to, should we store the letter or should we store just a character code right in there? We'll store the letter for now. We'll store the letter for now, so it'll be a string. And we'll call that, yeah, letters. It's good. And we don't need to pass anything in there as of yet. Now, or should we? Yeah, we should do that right in the constructor, really. Just populate our set with every sentence. So we just take sentence, and we can either actually let me just take a look at the docs here for set. What can you feed it when you actually construct it, when you instantiate it? Yeah, so you can give it an array, which would really be, okay, so any iterable. If an iterable object is passed, all of its elements will be added to the new set. Right? Now, here's the interesting thing that we can look at. I don't remember in JavaScript if strings are actually considered an iterable, because if they are, then I can just pass in the string, the entire sentence, and then boom, we've got what we need. So let's just do MDN string. I have a feeling that they're, well, they may be, because you can, I think you can use just a for loop to iterate through a string. Okay, our JavaScript strings iterable and iterable. There are many other built-in objects that are iterables as well. For instance, strings are iterable, so that should work. I shouldn't have to do anything other than, so let's forget about that here, but we'll have to type it. So we're expecting a set that's going to take a string. And now if we do this, new set string, and then just pass in our sentence. Now that's interesting, because if we do that, we don't even care to store the sentence. We've got our letters. So how about that? Yeah. Like that. Oops. Okay. So I'm curious. I'm curious to see what would. Let's just do. Okay, hold on. I'm going to use this little tool that I have called Quokka, which is. Whoop, I don't think I have it in this repo, in this project. Let's see. Quokka. Yeah, let's enable it in this workspace. All right, and I want to just make sure that I've got this right. Quokka. Okay, I think it started. Yeah, it did. Okay, good. So I'll just const foo equals new pangram, pass in a string of whatever. There we go. See? Beautiful. Beautiful. Okay, so we've got what we want. Now all that we need to do is basically check that we have. Oh, there's one thing though. I want to make sure that they're all lowercase. So 2 lowercase. So let's just check that again. Const foo equals new pangram. Let's add a few things in here. Okay, just want to check that. Ah, that works. That's good. Oh, wait a minute. Are we skipping somehow? I think it's just because when we're using this thing here, it won't show all of them. Or does it stop when it hits a space? Oh no, it's because, okay. It's because these are all the same letters. So it's just showing us, yeah, we've got an S, we've got a D, we've got an F, we have a space. Crap, we don't want spaces. That doesn't matter, I think, because if I look at what is the space? It's 32, so it's not even in the range. Anyways, I'm not sure yet how I'm going to implement the check of that, but this is doing what we want. It's good. Let's just, in case we want to use this again. All right. Now, how do we make our check? I think a simple reduce over, no, you can't use reduce on, no, just a for loop. Oh, really? All right. So I know the characters. Characters are from 97 to 122. So 97 to 122. So I could simply do for let I equals 97. All right. And we keep going as long as I is not as long as I is smaller or equals to 122. All right. And then we just do I plus plus. Yes, okay. Okay, and then all we need to do is, right, we need some sort of a flag here, which will be let has all letters so far. And we're starting off with true because so far it does. And then what do we do? We simply go, we check our, yeah, we check that has, exactly, has. This letters has, and then we, what if I go instead returns the Unicode value of the character at the specified location. Yeah, it would make more sense to do that check here. So, but then I can't, unless I convert. Is there a way in JavaScript to get a character, a string from its code, from its ASCII code? Let's take a look. JavaScript ASCII to car, I think is essentially what we're looking at. JavaScript string from car code. Looks like that's what we're looking for. All right. Do we have any working example here? No, we don't, but we can test it with Quokka. So string dot from car code, and let's just 97 should be A. Actually expecting a number. Okay, good. Yeah, there we go. 122 should be Z or Z if you're from the States. Okay, so that works. So now let's do that. Has string dot from car code. Boom, I. Hey, hey, hey. Okay. I'm rather pleased with that solution. Am I missing something here? So I'm doing this. If it has that, yeah, that works. So if it has that, we basically go has all letters so far equals. If it has it, it stays true. Now the one thing that we want to do is every time we need to check if as all letters so far ever becomes false, then we are done. We are done and we return false. If we go through the entire loop without ever being false, then we just need to return true. We could make this instead of being just true or false, we could return this. Right? Which is better. If it doesn't have all letters so far, then return has all letters so far. And if it does, then return has all letters so far. I don't know which one is clearer. I kind of like this. Okay, so this should work. Let's run our tests. And it passes. Yeah, we're good. We don't have any problems. And I think that's pretty much the extent of... I don't see Pangram with mixed case and punctuation. That shouldn't be a problem. We should be able to deal with that. That doesn't affect our algorithm at all. Nice. And the same thing with this, non-ASCII characters. We're not going to take that into consideration at all either. How cool is that? Okay, less than 40 minutes and we're done with a, I think, a pretty clever solution to this little exercise. All right. Using the actual codes instead of storing all letters and stuff like that. So there's one thing I want to do here is get rid of these magic numbers here so that people actually understand what's going on when they're looking at the code. So we're gonna make this, let's just make it a private and call this we're gonna call it let's make this very explicit. ASCII code for A is 97. And then if I make a private const, should I, technically I usually, when I name my variables and they're private, I put a trailing underscore. But if it's a const like that, I don't think I need to. It's pretty obvious that they're not supposed to be mutated. So I won't. Private ASCII code for Z. Now, maybe I should say lowercase a, because that would be more accurate. But, okay, let's not, well, I guess so. Lower case a, ASCII code for lower. It's better to have long names that are very explicit. So I is equal to this dot ASCII code for lowercase a and ASCII code for lowercase z. I don't really need to make those private, I guess. I don't even need to have them in the class, really. Where would be the best place to put these? They could be private static, too, which doesn't help us much, but doesn't make much of a difference. What would be the most idiomatic thing to do here in terms of TypeScript? Because I could simply do this. Would allow me to avoid having to use the this thing. Why don't I do that? Is that better? We're making sure that way that we can't, well, I could make it read only. I don't know. I don't know what I prefer. What if I was to, let's say, make it not private, but actually read only? Then, can you make something private read only? Ah, looks like you can't. I didn't even know that. How interesting. So private read only. Basically the equivalent of a const. And no one from the outside of this class can see it. But it wouldn't be a big deal if I was to make this public, but I'm not. So there. So ASCII code for lowercase a, and now we're going to change this to be ASCII code. Look at that. Huh? It seems pretty, now it's pretty easy to see what's going on here. I don't need a space here. So for ASCII code starts being the ASCII code for A, and we keep going as long as the ASCII code is not bigger than the ASCII code for Z. So it's pretty obvious what we're doing here. We're incrementing the ASCII code every time. Has letters so far. This letters has string from character code ASCII code. So that's, if you're familiar with the language, you know what's going on here. If has letters so far is not true, then we return has letters so far. Yeah. I could make this into its own method and call it like, because that's like implementation detail, right? I could probably hide that in another method and just call it has letter. I like that. I like that idea. Why don't I do that? I mean, it's maybe a little overkill, but it makes it very easy to understand what's going on in the is pangram function. has letter. Oh, and this will be private. Even. So, and now, instead of doing it this way, we could probably just do if has letter, right? Or if it doesn't have the letter, basically. If and we don't even need that flag, do we? If has letter. And the code is our ASCII code. Then we return false. Otherwise, just keep going. Once we're done, we return true. Ha ha ha! Like this, even more. Let's cut down some code. Just run our tests, make sure we didn't screw up anything. We're still good. So I'm pretty happy with this refactoring. I think we're going to go with that. I don't see what else would really improve this code. Okay, so how do I upload this again? Let's see. Let's go back to, I'm not going to need this anymore. Well, maybe. Submit. Exorcism, submit, path to file, right. So, exorcism, exorcism submit, and I am submitting. I am in the Pangram folder. I am, yes. So if I just do pangram.ts, I think this should work. Looks like it doesn't. TypeScript pangram.ts. What? TypeScript pangram.ts. What am I missing here? Pangram. Yep, that's the problem. Pangram.ts. Oh, there you go. Okay. And if I refresh, I guess, there we go. We've got our solution right there. Oh, and I can't request mentor feedback at all. Spites. I thought I could still request it. It was just that. All right, well, I'm just going to leave it as is, and when the time comes, I'll be able to request the feedback. In independent mode, you will not receive mentoring by default. You may request mentoring once your existing solutions have been mentored. What? Disabled. Mentoring is disabled by default. However, you can request feedback on a maximum of one. Oh, okay. You can't have no slots free. That's why. Okay. That's cool. Can deal with that. So now let's go back here and see what's next. What is next? If I was to switch to the mentored mode and I was to go through the usual thing I would have done. Oh, there's actually like a bunch of sub exercises. I should be like these here, but they're only unlocked once you have your solution mentored. So now I don't know which ones are associated with this. It's too bad. So just keep going with the main ones then. Bob is the next one we would be doing. Okay, so switch to independent mode. And let's look for Bob. Okay, they seem to be in order here too, I guess. Bob. Okay, what are we doing? Okay, let's first install or download, should I say, the exercise. Oh, I'm just going to first Pangram. Just going to commit my last changes to Pangram. So add complete solution to Pangram. That. Now let's get in there. Don't need this anymore. What? Bob. Bob is the one we're looking for. Bob. Okay. Install dependencies. Man, I really need to get a better chair. This is so uncomfortable. And desk, for that matter. Would love to get one of those pneumatic, like, lifting desks where you can work standing up or sitting down. I'm pretty tall too, so like it's hard to find furniture and desks that are the right height for me. Chairs. Okay, so we've got that. Let's take a look at our Bob here. Everything seems to be in order. Right away, I'm going to get rid of that annoying, what's it called again? No constructor parameter, I think it was called. No parameter properties. Bowls. There. And I'm just going to push that to GitHub. And we're going to call that add Bob. Yeah, exercise. Commit. I'm pushing that to GitHub, and just for the sake of my wonderful viewers, let me go ahead and change. Just give me a second here. Change the title, and I'll give you a link to the repo for Bob. To get in there here. So now we're working on Bob, and here's the repo. There we go. Okay, so what is Bob? Introduction. Bob is a lackadaisical teenager. Oh yeah, I love that word that I can't pronounce. In conversation, his responses are very limited. Bob answers, sure, if you ask him a question. He answers, whoa, chill out, if you yell at him. He says, fine, be that way, if you address him without actually saying anything. He answers, whatever, to anything else. Okay. That's all we get. Interesting. Interesting. So let's take a look at the, okay, we don't need this anymore. We're going to need to take a look at the tests to figure this one out. So we're expecting a class here that has a hey function. and it will receive some string. Okay, I get it. I get it. See, there's an exclamation point, so it's shouting. So we go, whoa, chill out. Shouting gibberish, so okay, don't necessarily need the exclamation point. It could just be all caps. Asking a question gives us sure, so as long as it ends with a question mark. Asking gibberish, still good. Okay, so we don't really care about the exclamation point. It's the all caps that's important in terms of shouting. Using acronyms in regular speech. Oh, that's gonna be, okay. So it needs to be the entire thing. That is all caps. That's not a big deal. Yeah. Forceful question. So if it's all caps and there is a question, then calm down. I know what I'm doing. Hey, actually, that wasn't even in the... Yeah, that wasn't even in... Shouting numbers. Whoa, chill out. Okay. So there's a bunch of different little things that we need to take care of. It won't be that hard. It's just... We're going to end up with a bunch of ifs and... Or maybe a switch. I don't know. We'll see. Figure it out as we go, one at a time. Okay, so first thing is we need a Bob class that has a hey function. So let's start. Oh, it's already there for us. Look at that. Hey parameter. I don't know why they do the export separately, but I feel like we might as well do it that way and save some space. Hey, parameters go here, so what should we call this? Sentence? Let's call it sentence. And it's a string. And we're just going to return, for this one, whatever. Sentence, because it won't compile otherwise. Whatever with a capital W. This should give us our first test passing. Oh, maybe not. Whatever with a period at the end. Try that again. Good. Next. Shouting. Watch out. So what's the easiest thing we can do to get this to pass? If sentence is equal to watch out, then we return, what are we supposed to return? Whoa, chill out. I need this to be a string, please. Thank you. Whoa, chill out. Otherwise, just return whatever. Okay. Test is good. Next. Shouting gibberish. Okay, so now we need to check for all caps. Is there an easy way to check that every single letter is all caps? That's interesting. I don't think there is. anything like that that we can use on the string. What do we have? Length index match is something we can think about. Starts with no, 2 lowercase no, big, no, blink. What is that stuff? No, no, no. Okay, we could use the ASCII characters. Returns a non-negative. I don't even know what that is. Concat ends with fixed. Font color. This is all HTML stuff. Includes no, 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 no. Determines whether two strings are no. Turns the string value result of normalizing the string into the nope. Nope, nope. No. What was that? Returns a string value that is made from count. Oh, these are all like new ES stuff. Huh. Replace, search, finds the first substring, no. Slice, small. Split. Strike, substring, sup. To lowercase, to string to uppercase, trim left to right value of, no. All right, so we're gonna need to make this. Oh, this is going to be, wow, okay. Okay. How am I going to do this? Because we need to check that the letters are all caps. Oh, we need to check that the letters are all caps, but we don't care about any other characters. You could have letters in there. You could have an exclamation mark, period, comma. So the smart thing to do would be to check that we don't have lowercase letters. So here's what we're going to do. I think we're going to need a private method for that. Private method. We're going to call this has no lowercase letters. If it has no lowercase letters, well, that doesn't automatically mean that it has uppercase letters. Anyways, it's going to pass that test, so that's what we care about right now. Refactor if we need to later down the line. So has no lowercase letters is going to well, it's going to return a Boolean, right? We know that. What's it actually doing? It's taking in our sentence. And we basically have to do the same thing we were doing in, or something similar anyways. So let's just get back to our pangram here. How are we doing this? We were just iterating through this. Let's use that as a starting point. So for let ASCII code equals this ASCII code for lowercase a. Well, this is actually pretty much what I was trying to do here. So let's just bring in everything. That too. And I'm going to use these. Okay. This has, okay, we just need to change this then. Has, no, this ASCII code equals, we're starting at lowercase a, we're ending up at lowercase z. If you do have that letter, yeah, we need to refactor this here. Because this isn't, and it's also not a set. Okay, let's just rethink this. Let's just rethink this here. If and what do we have to work with? We have our sentence here. So we can just do if sentence dot includes returns true if search string appears as a substring. Yeah, okay. Includes simply string dot from character code ASCII code. Now, if you have that, then you do have a lowercase letter. This should probably just be has lowercase letters. And then we return true. And otherwise, if we go through the entire thing, we can return false. Okay, I think we can work with that. If sentence includes string from character code, ASCII code. That seems pretty, yeah, I don't think I need to. Okay, now I do this. If this dot has lowercase letters, sentence. If it doesn't have lowercase letters, then we're yelling. Yep, let's try that. So that worked. Let's move on to the next test. Asking a question. This should fail outright. We should be returning sure when we see if we need some sort of way to, okay, if sentence dot, now I think I know there's a way to do this. To just get the last one. Trim left trim to uppercase substring, strike, slice, search, replace, repeat, pad end, normalize, link. Ends with returns true if the sequence of elements of search string converted to a string is the same as the corresponding elements of this object starting at end position minus length this. Otherwise returns false. What? I'm pretty sure that's what I need, but I'm not quite sure I understood the API there. So the search string is supposed to be a string, probably also works with a regular expression, but all we care about is finding this at the end. If I don't, okay, I'm gonna look at the docs here because MDN and string dot ends with. String that ends with best 17. Is this a question? Ah, that's exactly what I'm looking for. Ends with question. So we don't need to pass in the length. Optional if provided it is used as the length of str. If omitted, the default value is the length of the string. Okay, you could make that check somewhere in the middle of the string if you were passing in a length here, I think is what I understand from that. Okay. So this should do what we want. If sentence ends with this, then go ahead and return sure, I think it was, sure, with a period. Sure. Test. Passed. Yay. Moving on. Asking a numeric question shouldn't change anything at all. Let's try that. There we go. Asking gibberish. That too shouldn't make a difference. That worked. Now, talking forcefully. We should just return whatever. Don't need to change anything here. We're good. Using acronyms in regular speech. Since we have lowercase letters, we should just return whatever. Yep, good. Forceful question. Now that's a special case here. That's not going to work. That is not going to work. So we need a way to determine if we are well, we already have the ingredients to deal with this, right? If sentence ends with this, and if it has lower cases, then we're good. You can return sure. Otherwise, let's take for granted that that he's yelling at us. What am I doing? Okay, what am I supposed to? There you go. Calm down. I know what I'm doing. Let's try that. Pretty sure our test should pass now. Oh, no, it didn't. And we just screwed up a bunch of other stuff, apparently. Oh, it's the opposite. Silly me. Silly me. So I need this to be here. And this to be here. I think that should fix it. We're still failing. We're failing. Oh, we're picking this up first. We just need to change the order. That's not a big deal. Yep, good. All right. I was just thinking, hold on. I'm just wondering if I can refactor this here. So I've got this checked twice. Of course, in a different context. No, there's no way. It's either I make this check twice that has lower case letters, or I'm making the hold on. If I start by checking whether it has lowercase letters. No. Yeah, I don't. Okay, let's keep it like that for now. Let's add our new thing, shouting numbers, which should work. I think our implementation will pass the tests. There we go. And no letters should give us whatever. Ah, that didn't work. We got whoa, chill out. Why did we get whoa, chill out? Because we don't have any lowercase letters. If I was to add a check for numbers, maybe. Yep, why don't we do that? Private has numbers. Sentence. Sentence. String, return a Boolean. Essentially the same thing here, except that we need to change the codes from where are the numbers? Where are the numbers? Here. From 48 to 57. To 57. Let's just use these for now. Okay, now if it doesn't have lowercase letters, or it doesn't have lowercase letters and it has numbers. This dot has numbers. Makes for one heck of a long thing here, like that. Let's try that. Still didn't work. Did we screw up something? Bob, no letters now. It doesn't work. Yeah. Which one was it? No letters. Oh, that's the one I just... Okay, so that didn't work. Expected to have whatever, and we have whoa, chill out. Oh. It should just be that. If this has lowercase... If this has no lowercase numbers, letters, or if it doesn't have numbers. Right? Okay, I think this will work. I screwed up a bunch of stuff now. So no letters still doesn't work. I'm still giving whoa, chill out. Does that mean that if this doesn't work here? If sentence includes this, then return true. It's 48 to 57, isn't it? Yeah. What am I doing wrong here? So the test case we're interested in is fitting us just a bunch of numbers. There's no letters at all. So maybe really I shouldn't be checking for numbers, but I should be checking for all letters. And then I could have a check if it doesn't have any letters, then boom, whatever. I could make that check right here. So why don't we do that? Still, I don't get why this doesn't work. If this has numbers. Oh, of course, it's because we're being tripped up by this thing here. So maybe it should be end. If I do end, this doesn't have numbers. Maybe that'll work. It does, but it's screwing up shouting numbers now. Yeah. So let's forget about this then and go ahead with our other idea, which was to check for has letters. Pretty much already set up for that, so we're going to make two of them. Has. This one will be has capital letters, unless they are. No, they're not. So I was going to say if they're like if it would have been 65 straight through to, 122, but it's not. There's a bunch of stuff in between. So Let's make them separate. As uppercase letters. We'll come back to the codes later. So I'm working with 65 to 90. 65 to 90. 65 to 90. Has uppercase letters. And now what I can do is if this dot has lowercase letters and what am I doing? Okay, and this dot has uppercase letters. So if it doesn't have that, then go ahead and return whatever. But that's going to screw up the case where we have numbers. Okay, and it has no numbers. And it has no numbers. This dot has numbers. Okay, I think I know why it wasn't working before. I wasn't actually calling the... was I? Kind of weird that it wasn't... Okay, let's take a look at this now, see if that works. Nope. What now? The no letters still doesn't work. Everything else is fine, but the no letters, we're still getting whoa chill out. How can that be? Oh. Because we do have numbers. Crap. Now if I remove this, that test case is going to pass, but it's going to be another one that's going to blow up in our face. Oop, what have I done? Declare was never used. Yeah, okay. I'm cool with that. Just comment that out for now. Oh, it worked. Oh, that's interesting. I thought asking a numeric question. No, that's being picked up by our first check here. But what about shouting numbers? How am I... If it has no lowercase letters and it has no uppercase letters, it should be returning whatever. So how come shouting numbers makes its way to this one here? Does it have a capital letter? Shouting numbers. It does. Ha ha ha. It's got go in it. Right, of course, because otherwise it wouldn't be considered shouting if there wasn't some capital letters in there. Because we've determined that just the exclamation mark is not enough to warrant a whoa, chill out response. Okay. Good, 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 good. Let's keep going. Question with no letters. That should be picked up. We shouldn't have a problem with this. Or not. How is that? Question with no letters. So it's picking up this. We know that. And now it has no lowercase letters, so it's going boom. Boy. So in the case where this has lowercase numbers, if this has lowercase letters, Now, if this doesn't have any lowercase letters and also doesn't have any numbers, I knew this would come in handy. Kind of a cheat here, but it'll work. And this has numbers. So, because I think that's what they're doing, right? They're asking a numeric, no, what are we doing? Question with no letters. Yeah, this should work. Or not. Now we're screwing up the forceful question. The forceful question is it has a number? No, it doesn't. What the hell were you thinking? And I'm saying here, if the sentence says this, yeah, and it doesn't have any lowercase letters, and it doesn't have numbers. There's probably something wrong with my has numbers thing here. So let's test it out. Oh, did that again. Forgot. Dumb. There we go. Okay. Next. Shouting with special characters. That pretty confident is going to work. Yep. Next. Shouting with no exclamation mark. Yeah, we already knew that was coming, didn't we? So we shouldn't be tripped up with that. Yep. Statement containing question mark. We're good because we're only checking for it at the end. So that shouldn't be a problem. Yeah. Prattling on. Oh. This. Nope, that's gonna work. I think we'll be fine with this one. Yeah. Silence. Oh, we don't have that. What was the first test case? It was just whatever. Okay. And now silence. Fine, be that way. That'll be an easy one to fix, though. Fine, be that way. Very first thing we'll check for. If sentence equals this, return fine, be that way. If. Let's run the test. Now what? Oh, it's not, it's just an empty, I thought it was a space, but it's an empty string. Okay. Okay. And then, okay, there we go. Prolonged silence, so we're going to need to deal with this some of the way. It's an easy way to deal with this. What's an easy way to deal with this? Check if string is empty. There's probably an easy way to do check. Can't type JavaScript. Check if string is empty or white space. How to check if string contains characters in white space. That is old. What's the best way to check if a string contains only white space? The string is allowed to contain characters combined with white space, but not just white space. That's pretty much what we're doing here. So instead of checking the entire string to see if there's only white space, just check to see if there's at least one character of non-white space. Well, that's not that's not stupid at all, right? This .s, what is that one? Regexer. Character classes. Match any? That's what it is. A character set that can be used to match any character, including line breaks, without the .all flag. So what is he doing there? He's testing to match any character. That's what everyone seems to be recommending. If your browser supports the trim function. Oh, that's not bad. That's not bad at all. Because trim will get rid of all the white space, any kind of white space. Then once you're done doing that, first condition to check if string is not empty. Second condition to check if string contains just white space. Yeah. I like that. I might go with that. So if sentence is equal to sentence.trim, because trim will return, removes the leading and trailing white space and line terminator characters from string. Yeah. So, oh, hold on. Will string actually return? So mdn string dot trim. Returns a new string representing the calling string stripped of white space from both ends. So technically, all I need to do is check if sentence because an empty string will be falsy. So if after doing this, there's nothing left in the string, it'll be an empty string. It'll be falsy. If it's falsy, then fine, be that way. Let's try that. Yeah, okay. Cool. The things you find on the internet. Alternate silence, what is that? What is that character? T. An escaped T. I don't think I've ever used that. But what you know? That means that trim takes care of it. But what is the escaped T? I don't know that. So T and B do. Oh, could it be a tab? Like instead of being a space? Oh yeah, that's what it must be. It's a tab, okay. And trim is smart enough to take care of that tab. There we go. Okay. Nice. So that was a good choice. I didn't even know it, but that was a good choice. Okay. Multiple line questions. Oh. How? I'm supposed to say whatever to that? I think that'll work. Because it doesn't end. The string doesn't end with, yep, I'm dealing with it properly. Good. Starting with white space. Yep, that's going to work. We're good. We're good. Trudging along. Ending with white space. Not going to be a problem either. Oh. Okay. So, what is going on here? If, like my spacebar, quite a bit. So trim is supposed to get rid of that white space. Is trim removes white space from both white space in this context? Does it actually mutate a new string representing the, okay. So I should just do, that then. Sentence equals sentence dot trim. And then I can just do if sentence. I think that should be okay. Please let it be okay. Yep. All right, maybe a space here. And we're almost done. Other white space. Let's see how we deal with that. Trim, I think, is smart enough to deal with that. Yes. Good. And non-question ending with white space. Don't think that's going to be a problem. There we go. Ta-da! Another successful exercise. Now, shall we refactor? We probably should. Now, here's one thing that strikes me as we've got duplication here for sure, right? We're doing the exact same thing. We're doing the exact same thing here. Now I've got two choices. I could make one general function that takes in the sentence, that takes in as a parameter a starting ASCII code, an ending ASCII code. And I could do that. But then, in my hey function, which contains my general algorithm, instead of having this neat has lowercase letters or has numbers, I would have all over the place this has, has character contained between, and then I would have to pass in the ASCII code. And so here's one thing I could do. Maybe I could try to extract this into a separate function and still keep these three. So basically this would be wrapping another function. Why won't it let me extract this easily? I'm not sure. But let's do it by hand then. Private has characters between That's what we're going to do. We're going to need to pass in the sentence. Really seems silly that we always have to pass in the sentence to the... Really, the sentence should have been passed in through the constructor, but whatever. Because otherwise, why not just make that a static? Anyways. So we need the sentence. Maybe the sentence would be last. Has characters between, and then we take in our starting character code, which will be a number. And then our ending character code, which will be a number. And then our sentence, which will be a string. And we are returning a Boolean. Right? Okay. And now what are we doing? We're doing this essentially. This is ASCII code, then this is going to be replaced by starting car code, and this will be ending car code. And we've got our sentence already, we've got our ASCII code, everything else is good. So I'll probably want this to be after all of these. And now all of these, instead of, so for instance this one here, instead of doing all of that, can just go this dot has characters between, and then we're this dot ASCII code lower a, this dot ASCII code lowercase z, and then just pass in the sentence. So let's make a test, see if we screwed up something. Yeah, looks like we did, because we're not returning this. There we go. All right, seems sound. Let's do the same with the other ones. We just need to return just this here. And instead we're using 65 and 90. Okay. And same thing here. We're using 48 and 57. Like that. So that looks good. That looks good. So we've eliminated a few lines of code. And let's just make sure that didn't screw up anything. Yep, we're still good. Now I'm thinking, right, because we shouldn't have these magic numbers here either. But I kind of hate having a bunch of private read-only properties on there that I'm not going to use anywhere else. So why not just put them in the function themselves, right? We could do that. And that's what we're going to do. If ever we needed to use them somewhere else, it would make sense to have them more like available to the entire class, but we don't. Just like that. There we go. We're going to do the same thing here. Here we're checking for uppercase letters. So 65, 90. ASCII code for upper. And then this and that. Okay, and same idea. ASCII code for 0. It's 48. Is it? I think it's 0 to 9. The way that it's done. Yes. 48. Look at 57 here. ASCII code for 9. Got 5 minutes left to refactor this before I need to go. Okay, run the tests again. We're good. Now, yeah, I normally I'm not a big fan of a lot of if statements, but sometimes with these algorithms it's kind of hard to, could I have a switch statement instead? Would that make it easier? I don't think so. You can't really have expressions in the case statement, right? And it really isn't that bad. I only have one nested if. I'm not using any else's. I'm always using if return. My general case is here. If you trickle down to the bottom, I mean, I could start, making something complicated with other objects and whatnot, but you'd still need some sort of you'd still need some conditionals. There's not much behavior here too either. We're just returning a string, so really I think that's the best way to go about this. And I'm pretty satisfied with the way I'm checking for specific characters. I think it's pretty clever, but I'm finding a way to make sure that everybody understands what I'm doing here. So I think I'm going to go with that. So what was it again? Exorcism, submit, and then the name of the file, bob.ts. Let's make sure this worked. Nope. Here. Refresh. It did. There we go. Not bad. Not bad. Pretty clean code, I would say. I think. Okay, so that's it for me. I will just push that to GitHub as my final act of this live stream. So add solution to Bob exercise. There we go. So thanks for watching. See you tomorrow. Tomorrow will be at 1:30 p.m. Eastern Time. Take care.